Now, the good news is, as far as multiplying radicals goes, it's really like one extra step from what you guys have been doing the last couple of days, and then it's the exact same thing you did on Monday and Tuesday. So, whenever we talk about multiplying radicals, alright, so, first of all, and this isn't going to be a huge issue this year, this class, this chapter, this section, but just something to kind of be aware of. When we talk about multiplying radicals together, you are only allowed to multiply radicals that have the same index. We talked about index back in chapter 7, which I know you guys all remember because, you know, it's really interesting stuff. But the index is a little number up here on the outside of the radical sign. If you don't see one, which most of the time you don't, it defaults to a 2, and it's a square root. If you do see a number, like a 3, it'd be a cubed root or a fourth root or a fifth root. So, if by chance you were in a situation where you had 2 square roots multiplied together, they didn't have the same index, you would not be able to multiply them together. All right? Now, if they do have the same index and you can multiply them together, there's kind of 2 big things to watch out for. That third thing is the one we've been doing the last couple of days. So the first thing, whenever you look at the numbers, you know how sometimes there's numbers already outside the radical, and then of course you have the numbers under the radical. When you're multiplying radicals together, if you have multiple numbers outside the radical, you can multiply them together, and they have to stay outside the radical. If you have multiple numbers under the radical, you can multiply them together, and they have to stay under the radical. So that's kind of the first 2 rules there. And then once you do that, you're going to take these 2 radicals and then multiply them together and turn them into 1 radical. And then you're just simplifying radicals using the cake method or the perfect square method that I mentioned to you guys yesterday. So let's try this first one here. So if I were to take the square root of 3 times the square root of 6, the 3 and the 6 are both under the radical. They're in the same place. So you can multiply them together. You take 3 times 6, you get 18. But since they started under the radical, when you multiply them, they have to stay under the radical. So I get the square root of 18. Now, once you do this step, guys, it's the same as yesterday. You wouldn't leave your answer like this if it's not in simplest form. How do you know if it's in simplest form? If it has any perfect square factors. Or cake it, right? If you were to cake 18, you could divide out of 2, you get 9. Out of 9, we could divide out of 3, you get 3. Out of 3, divide out of 3, you get 1. And then if I were to go back, I have a pair of 3s. Remember, the pairs come outside. That 2 that didn't have a pair would stay inside, so you would get 3 square roots of 2. If you liked the perfect square method that I showed you yesterday, remember you're looking for those perfect square factors, the 1, 4, 9, 16, 25, 36, and so on. The one that goes into 18 would be 9, right? 9 times 2 would give you 18. You can take the square root of 9, you get 3. You can't take the square root of 2, so it stays the square root of 2. Either way, right? Now, if I look at this one, where I have numbers outside the radical and inside the radical, if the numbers are in the same spot, you can multiply them together and keep them in that spot. So, in this case, the 2 and the 4, see how they're both outside of the radical? You can multiply those together. 2 times 4 is 8. They stay outside the radical. Now, the 12 and the 15 are both under the radical. You can multiply them together, and then they stay under the radical. And 12 times 15 gives me 180. Once you get to this step, it's the same as yesterday. So you're either going to do the cake method or look for perfect square factors. Kind of like I told you yesterday, if it's a smaller number where you're maybe a little more familiar with the multiplication facts, I might do the perfect square factor method, but I don't know about you, I'm not super familiar with all the factors with 180. It's kind of a bigger number, so this is one that I probably default to doing the cake method. So if I were to cake 180, what can I divide out of 180? A 2, 180 divided by 2 would give me 90. What can I divide out of 90? Another 2 we get 45. I could divide out a 5, and I'd get 9. 3, I'd get 3. Another 3, and I get my 1. Now remember, guys, you can only divide out prime numbers. Okay? So if I go back, I have a pair of 2s, and I have a pair of 3s. Now here's, just like yesterday, you need to be careful because the 3s make 1 3 outside, the 2s make 1 2 outside. So I have 3 times 2, which is 6. Times 8, yes, very good. 6 times 8 is 48, and I'm left with a square root of 5 on the inside. Don't forget about that number that's already on the outside. So, the only thing new today is going from this to multiplying together to one radical. That's the only thing that's new today. All right? So, let's get this glued, and this should be page 55. All right? Yeah, 55. This is still section 10-2, multiplying radicals. Okay, so I kind of mentioned on the left-hand side that there's really one step that's new today, and the rest of it's just simplifying radicals again. So, let's look at number 1 here. Number 1 says the square root of 3 times the square root of 2. The biggest thing you need to remember is that you can only multiply numbers together that are in the same spot. Since the 3 and the 2 are both inside the radical, they're in the same spot, you can multiply them together. So 3 times 2 is 6, but they have to stay under the radical. Once you get to this step, it's the problems like yesterday. So you would need to make sure this is in simplest form. So either look for those perfect square factors, or if you're not sure, you can't find any perfect square factors, you would just cake it. But here's what happens when you cake 6. If I divide out of 2, I get 3. Divide out of 3, I get my 1. My cake's done. Do I have any pairs? Yeah, okay, that's a good way to look at it. So there's no pairs, so these would both stay on the inside. 3 times 2, square root of 6. Yeah, all this means is already in simplest form. Like a fraction 2/3. Already in simplest form. You can't reduce it anymore. The square root of 6 is just the square root of 6. Another way to just reassure you that it is in simplest form, remember those perfect square factors are 1, 4, 9, 16, 25, and so on. We're looking for numbers that go into that number that can be divided by that number. So first of all, it has to be a number smaller than 6. And 4 is the only one, and you can't divide 6 by 4. Right? So it doesn't have any perfect square factors, which is why it is in simplest form. Okay, number 2, the square root of 6 times the square root of 2. The 6 and the 2 are both under the radical, so you can multiply them together. 6 times 2 is 12, but they have to stay under the radical. And then we're just looking to simplify this. So, if you like the cake method, this is a pretty easy one to simplify by the cake method. We can divide out of 2, we get 6. Divide out another 2, we get 3. Divide out of 3, we get 1. So I have a pair of 2s. So I have a 2 on the outside. And I'm left with a 3 on the inside. If you like the perfect square factor method, how would you break down the 12? 4 and 3. Excellent. 4 times 3. The square root of 4 is 2. The square root of 3 is 6. The square root of 3. Either way works. Whichever you're more comfortable with. Okay, number 3. Number 3 says 5 square roots of 10 times 2 square roots of 15. Now this one, the 5 and the 2, outside the radical, they're in the same place. You can multiply them together. 5 times 2 is 10, but they should stay outside the radical. The 10 and the 15 are both under the radical, so multiply them together. Keep them under the radical. 10 times 15 is 150. And then whether you're doing the perfect square factor method, let's say, what if you are doing the perfect square factor method? Anyone jump to your mind real quick? Multiples of 50. What perfect square is going to go into 50? 10's not a perfect square. 100 is, but not 10. 25. 25. 25 times 6. 25 times 6. The square root of 25 is 5. You can't take the square root of 6, so it stays the square root of 6. But guys, remember, biggest thing here, there's already a 10 out here. There was already a 10 out here, so you would take 10 times 5, and you would get 50 square roots of 6. If you're doing the cape method, on the side of your cape, you should have a pair of 5s, and left with a 2 and a 3 that go back inside. Okay. Number 4, -4 square roots of 20 times 3 square roots of 10. What can I multiply together? Right, the -4 and the 3 gives me -12. They stay outside, and I can do the 20 and 10, because they're both inside and they stay inside. Now I'll kind of jump back and forth between the perfect square factor method and the cape method, since I did the perfect square factor method for the other one. I'll do the cape method here. If you're doing the perfect square factor method, this is an easy one. Okay, we'll come back to that. But if I'm going to do the cape method, I'd probably divide out a 2 and I'd get 100. Divide out another 2, I could get 50. Divide out another 2, I'd get 25. And then I have a couple of 5s to divide out. So still not a difficult cake. But I would have a pair of 2s and a pair of 5s. Remember though, whether you're doing the perfect square factor method or the cake method, you take 5 times 2, which is 10, times what else? Times -12. You get -120 square roots of 2. If you're doing the perfect square factor method, this is one of the ones we talked about yesterday. What's the easy one here? 100! Yeah, 100, that's an easy one to see. The square root of 100 is 10 times -12, left with a 2 on the inside. Either way works. Okay, like I said, like I promised, right? It's really one extra step, and then it's the same thing as yesterday, just more practice from what we did yesterday. Okay, number 5 says the square root of 40x squared times the square root of 10x cubed. Now, both of these are under the radical, so you can multiply them together, even the variables. So we would take 40 times 10, which is 400. Now review our exponent rules here. What happens when you multiply x squared and an x cubed? You add them. So we would have x to the 5th. Is this inside or outside? Inside. Yeah, it stays inside. Now this one's an easy one too. Right. What could you do with 400? 100 times 4. And this one actually works out kind of nicely anyway, because the square root of 100, 10, square root of 4, 2. 10 times 2 is 20. Because guess what? What's the square root of 400? 20. Isn't 20 times 20 give you 400? Yeah, it's a perfect square. Now for the x to the 5th, remember we're pairing up the variables. How many pairs can you make out of x to the 5th? 2 pairs, right? So we have an x squared. Anything that doesn't have a pair? Goes under the radical. There's that 1x, right? Anytime you have that odd number, you're going to have that leftover 1. Okay, let's do just one more. Let's do -10. Don't need to parentheses there. I'll just go over here. Okay, -10 square roots of 5xy squared times -3 square roots of 15x squared y. Now this one I think just looks different. It just looks a little more complicated because you got the parentheses, the negative number. But it's the same thing, it's just a multiplication problem. What numbers are on the outside? The negative 10 and the negative 3. Negative 10 times negative 3 would give me a positive 30. And then just take it piece by piece. So under the radicals, start with your numbers. 5 times 15 is 75. When you take x times x squared, what do you get? X cubed, excellent. And then kind of the same thing happens with the y's, right? Y squared times y, 2 plus 1. You'd also have your y cubed. Now to simplify this, we'll jump back to the cake method. For those who like the cake method, what can I divide out of 75? Of 5. 75 divided by 5 would be 15. I could do a 3 and I get 5. Divide out of 5 and I get 1. Now I'm glad that we did it this way. Because when you go to look at your cake, I have a pair, but they're not next to each other. Do you think it matters? No, it doesn't matter. Because right here from 15, instead of dividing out of 3, I could have divided out of 5 if I wanted to. And if I would have divided out of 5 instead, 15 divided by 5 would give me 3. And guess what I would have divided out next? The 3. And then they would have switched. It doesn't matter if they're next to each other or not. It's just kind of nice when they are. But they don't have to be next to each other. So you have a pair of 5s times 30. So 30 times 5 gives me 150. I'm going to leave a little gap there for my variables. What's left on the inside number-wise? 3. Now I have x cubed. How many pairs? 1 pair. And since it's an odd number, right, you're going to have that one lonely x that's left on the inside. And the same thing happens with the y. So 15xy, square roots of 3xy.